831 is how can I predict the output, functions and graphs and tables. So this is going to be kind of your first lesson on functions. Throughout this course, you have used rules that relate two variables to make graphs and find information. An example of such rule is y equals 5x minus 3. Today, you will look more closely at how rules that relate to two variables help establish relationships between the variables. So starting at 117, function machines. A function works like a machine. Numbers are put into the machine one at a time, and then the rule performs the operation or operations on each input to determine each output. For example, when x equals 3 is put into the machine with the rule y equals 5x minus 7, the rule multiplies the input 3 by 5 and subtracts 7 to get the output, which is 8. The input and output can be written as an ordered pair 3, 8. Then it can be placed on an xy coordinate graph. Find the output of the function machine at right when your input is 4. So I'm going to help you here. We have y equals 5x minus 7. So y equals 5 times your input, which is 4, minus 7. 5 times 4 is 20, minus 7, so y equals 13. So your ordered pair then would be 4, 13. I would like to try B. Okay, if you're back with me, you've tried B. So we're going to substitute in -1 for x. -5 minus 7 is -12. So your ordered pair is -1, -12. And when x is 10, 5 times 10 is 50, minus 7 is 43. So your ordered pair is 10, 43. Hopefully you got both of those correct. C says, if the output of the relation is 45, what is the input? That is, if y equals 45, then what is x? Is there more than one possible input? So now we're kind of switching gears. Instead of substituting for x, we need to substitute for y, which we've done in class. So 45 equals 5x minus 7. Add 7 to both sides, and we get 52 equals 5x. Divide both sides by 5, and you get 10.4 equals x. So could we have more than one output here? No. There's only one possible solution. Okay. So moving on to 118 now. Some relationships are special in that they are called functions. Below are two relationships of which y equals x squared minus 2 is a function and the other x equals y squared minus 2 is not. Look at the graph and the table of the values below for each relationship and discuss with your team why you think the relationship in part A is the function and why the one in part B is not. Use your ideas to create a definition of a function. Be prepared to share your ideas with the rest of class. Use these questions to guide your discussion. What is similar about the two relationships? What is different about the two relationships? What can we predict about the outputs for each relationship of the given input? Okay, so let's kind of walk through this together. When we're looking at our relationships here, we notice that both have a squared variable. What is different about the two relationships? This is y equals x squared minus 2, and this is x equals y squared minus 2. So one has x equals with the y value squared. The other has y equals and the x value squared. What can we predict about the outputs for each relationship for a given input? So here, if I have -3, 7, -2, 2, -1, -1, 0, -2, 1, -1, 2, 2, 3, 7. Okay, so here, we have some repeat y's. Here we have 7, 2, -1, -2, -1, 2, 7. So we have some repeat x's. So here's repeat x's, here's repeat y's. So when you have a function, you should only have your y values repeating. You should never have x values being the same. So what can we predict about the outputs for each relationship? So here we want to say for every output, there should be only one input. That's important because this is not a function. For every output, which is your y's, there should be one input. Okay, 8.1.19. Examine each of the relationships below, compare the inputs and outputs of each relation, and decide if the relationship is a function. Explain your reasoning. Use your definition of function from problem 118 to help justify your conclusion. So A, we're going to do the first one together. So this is yes, because each input, remember, each input, 7, -2, 0, 4, 9, -3, 6, has only one output. Flip it over. Let's try B. 3, 4, -1, -5, 2, 9, 0, 7, 1, 4, 2, -8, 9, 2. I see 2, -8, and I see 2, 9. So no, x equals 2 has different outputs. That's not allowed. C, I'm going to show you something when you have a graph. When you have a graph, you can do something called the vertical line test. So if I were to draw vertical lines through the graph, these vertical lines should only intersect the graph figure at one point. But here they intersect at 2. So no, okay, does not pass the vertical line test. Or you could say a lot of x values have more than one y value. Okay. I would like you to try D, E, and F on your own now that we have gone through those, and we will save those. And if you have any questions, then you can ask. That is it for today. And if you have any questions, please make sure you ask.